In this video, we will discuss about the wave topics. What is wave? How one can define the wave? The wave is nothing but a disturbance which will be created in a medium and which may be in organized manner or which may be in an unorganized manner. Like when you drop a pebble in a water, you can see the certain wave motions in the water. So let's define the wave now. A wave, a propagation of disturbance from place to place in a regular and organized way. Means when you drop a pebble in a water, so you can see that there is a regular up and down form of wave moving, which will be in an organized manner. So in that wave, we have the types of wave. One is the mechanical wave. Here the thing is the wave require a material medium for their propagation. Means to travel a wave, the wave require a medium. So for example, sound wave stretched in a string are the example. And one more is non-mechanical wave or an electromagnetic wave. Here these waves don't require any material medium for their propagation. So when you see a sunlight, you can see the rays are coming from far away from sun. So it don't require any material medium for their propagation. But when the light enters into a medium, its velocity may change, that may increase, that may decrease based on the mediums. In some mediums it will increase, in some medium, most of the medium, it will decrease. So these waves are also known as electromagnetic wave. What is their example? I told light wave and X-rays. So there are two types of mechanical wave: transfer wave and longitudinal wave. Means this mechanical wave, what they require? Material medium for their propagation. So first is the transfer wave. In the transverse wave, the particle of the medium oscillate in direction perpendicular to the direction of propagation. Means if the wave is moving in one direction and the particle will be propagating in the perpendicular direction, that is like if the wave is moving in this direction and particle in the medium oscillate in this direction, that is, let's see how it oscillate. Example, wave stretched in a string or wave on a water surface are the transferred in nature. Notice transfer wave can travel only in a solid and surface of the liquid. Means these transfer waves can be found only in the solid and on the surface of the liquid. Transfer wave propagate in the form of crust and trough. See how this crystal trough is noted. See, you can see over here, this is the crust and the bottom one is the trough. So the distance between this consecutive crust and crust, which we know as a wavelength. So you can see here the wave is propagating in this direction, but the particle in this wave which are oscillating in upward direction, that is, wave is moving in this direction and particles are oscillating in this direction. Now, as I told earlier, all electromagnetic waves are transverse in nature. Means electromagnetic waves are nothing but the light waves. One more is the longitudinal wave. In longitudinal waves, particles of the medium oscillate about their mean position along the direction of wave propagation. What does it mean? Means here the particle of the medium oscillate along the same direction of wave propagation. Means if the direction of propagation of wave is in this manner, and how the particles in this medium will oscillate is in this manner. that is compression and rarefaction. Now let's see how. Sound wave in an air or longitudinal. These waves can travel in solid, liquid and gases. You know that sound wave can travel in all this kind of material like solid, liquid and gases. So one is like how they travel is compression and rarefaction. Like this compression, once this compress and this compression will move further and further and becomes rarefaction. The distance between the compression of one from one to this, let's suppose this two, we known as the wavelength of that longitudinal wave. So this is the propagation of wave as I told, and this expanded part is known as the rarefaction. Let's see the equation of an harmonic wave. An harmonic wave are generated by a source that executes the simple harmonic motion. Let's consider a simple example, bob tagged to a wire. When this oscillates like this from this main position, it will go to highest position of this side and highest position of this side based on the force given to the bob. So this what this motion is known to be as periodic motion. Suppose this is also a simple harmonic motion. So harmonic wave traveling along the positive direction x is represented. How one can represent this wave as y is equal to a sine omega t minus kx. So one other type can be represented as 2 pi. Omega is equal to 2 pi by 2 pi into f. Okay, but f is equal to, we know f can be represented by 1 over t. Okay, 1 over t. So k also can be represented by k is equal to 2 pi by lambda. So one can take out 2 pi common out and we will be left with this expression. So where y is the displacement of the particle of the medium at location x at a time t, a is the amplitude of the wave, lambda is the wavelength of the wave, t is the time period, omega is the angular frequency, k is the propagation constant, or you can tell as an angular wave number. The harmonic wave travel along the positive x direction is represented by this expression. Suppose if it is traveling in the negative, this is the positive case, this expression. So if it is in the negative direction, so how one can write is y is equal to a sine omega t plus kx. Here there is a negative sign, here there is a positive sign. Here this positive sign represents that wave is traveling in the negative x direction. This is the direction of propagation. So similarly as this, we can write this one. How one can represent the differential equation of the wave motion, which can be written as d square y by dx square is equal to 1 by v square d square y by dt square. The relation between the wave velocity and particle velocity is given by the equation of the plane propagating is given by this expression, which is in the positive x direction, and the particle velocity can be represented by just differentiate with respect to t. So we'll be getting a omega cos omega t minus kx. Slope of the displacement curve or the strain. So how one can find the slope is differentiate dy by dx, means differentiate with respect to x, this expression. So we'll be ending with minus kx cos omega t minus kx. Now let's solve the problem related to what are the things discussed till now. So you will get an idea about the wave. The given question is the displacement y produced by a simple harmonic wave is given by the expression y is equal to 10 by pi sine 2000 pi t minus pi x by 17. What will be the periodic time and maximum velocity of in the medium? Here we need to find out the periodic time and the maximum velocity. Firstly, we have to know that how the wave is displacing in that medium. Firstly given is the wave expression, and we can write as another form like this: sine 2 pi 10 by pi sine 2 pi 1000 t minus x by 17. And we can compare with the general form of simple harmonic wave, that is given by y is equal to a sine 2 pi t by t minus x by lambda, that is equation 2. Now compare this a and the t expressions. So we will be getting t is equal to 1 by 1000. We can write that one in terms of powers, that is 10 power minus 3. For finding the maximum velocity, what we have to do, just differentiate the given expression, that is y is equal to 10 pi sine 2000 pi t minus pi x by 17. Vmax is equal to dy by dt. So 10 pi into 2000, differentiation of sign is cos x, 2000 pi t minus pi x by 17, 2000 into pi, that is this expression. So cancel pi and multiply these two, we will be end up in this 20,000 per centimeter per second. So this is the maximum velocity that the particle is executing in that medium. So one more way you can write is V maximum can be written as amplitude times the omega. Here omega represent the 2000 value and amplitude is 10. So just by multiplying amplitude and omega, you will be getting the same expression, 20,000 per second, 20,000 centimeter per second. Therefore maximum velocity is Vmax is equal to 20,000 centimeter per second. Thank you.